right, so today we're going to talk about transformations of basically any function. Um, all the functions that we looked at so far follow these general trends. Again, it's just really about like what is the function, and then looking at the numbers kind of around them and how they work. So again, this is just the general way we know and not annotate we the notation for transformations. We talked about if this a value is generally a dilation, is a vertical stretch, or a vertical shrink. And if it's a negative value, we do have a reflection over the x-axis. Now, I think for some of us, I think what helps us to remember that really is using the amplitude. Remember how we talked about something like 3 sine of x compared to sine of x? My amplitude is much greater here. It's a value of 3. So if my sine function looks something like this, my 3 sine is going to look something like this, where it's, okay, maybe that's exaggerated, but it will be 3 times as high because it has a 3 in front. So hopefully that kind of helps you to keep in mind, dilation, if it's greater than 1, it has a vertical stretch. But of course, generally speaking, we're just going to say there's a dilation by a factor of whatever the value is. And again, you have to be very careful because the a value, if it's negative, there's really 2 parts. One is that a reflection, and the other part is the dilation portion. So we'll talk about that as well. Now, I do want to emphasize here that if you are adding or subtracting, right, inside the main function, you can see that it's f of, right, x minus h. It's inside this function. It is a horizontal, it's a horizontal translation. And the sign is opposite. So if you have a minus h, it's going to be right. A plus h is going to be left. Okay. Now, again, we're going to talk about this more again later. But again, it's just really about, if you think about it, right, if I'm subtracting some number, x minus some number, I'm kind of delaying that value, or I'm delaying what's happening. So that's why it's to the right instead, and vice versa for plus h. But anyway, and finally, if we have plus k, what I've been saying is, if you take a look, it's kind of like outside of everything. It's like kind of like everything here, like this is done, right? After everything is done, now you kind of tack on this plus k. Therefore, it's kind of like whatever value you found, right? Let's say, oh, I did all this, I have my value here. Oh, but then I have to add k, so that I go up k units, right? So then I go up here. So it's just vertical translation. So again, I hope that you remember all these things that we have worked with. And I'm trying to go a little more conceptual here to help you remember. So here, for example, what I have is, I wanted to turn the type function first. I have x squared. This is a quadratic, or if you say polynomial, is technically correct as well. We're going to describe what kind of transformation has occurred. So let's do with the one that are a little bit more straightforward first. Like I said, this a value here, I have 2 things going on. So I'm actually going to use 2 different colors to try and differentiate them. The negative does tell me there is a reflection over the x-axis, while the 2 is going to tell me that there is a dilation. Okay, specifically, there is a vertical stretch. So there is a dilation by a factor of 2. Okay. All right. Now this next part, I'm going to try something, I guess, maybe a little bit different. But if you take a look at your original function, right, it's x squared. Where is that, like, x squared? Well, that x squared is here, right? It's this x, and now I have a parentheses squared. Like, that's the main function, right? And so I can see that my minus 3 here is being done to the x directly. It's not outside of the main function like this. It's inside. It's inside, being done to the x directly. So therefore, I know that this must be a horizontal translation. And again, the sign is opposite. Minus means to the right. Right 3. Okay? Here I do have a square root or a radical. I'm going to call this a radical for now. Right, and again, radical is this symbol right here. Okay, so I do have a 5 in front of everything. Right, again, my main function is square root of x. The square root of x is on over here. So this is going to tell me there is a dilation by a factor of 5. Once again, I'm going to take a look at, okay, well, my main function is what? My main function is the square root of x. So where is that? Well, I have the square root here, but now it covers more than just x. It covers x plus 1, right? So this is, again, the x, the plus 1 is being done directly to the x. It's been kind of adopted almost by my function, right? Now it's not no longer just x, but x plus 1. This is going to give me my horizontal translation. And again, opposite, so left, because it's plus, left 1. And finally, notice again that I have this, like, everything is done. This part is done. Everything I'm doing is it's done and over with. This -3 is an afterthought almost. This is going to be my vertical translation. And again, it is going to match whatever sign it is, so minus means down. I have, again, so you can see that this is an exponential function because my x is in the exponent, right? Exponential function. And again, maybe it helps you to say, okay, well, my original function is this guy right here, 2 to the x. Where is it? Well, 2 to the x is over here. 2, and specifically, it's now 2 to the x plus 7. So this is my main function. This tells you that's my a. That has to be my k value. Okay, so I mean, I don't know if that helps or not. I do hope that helps. But here I do have 1 over 4. This 1/4 is a dilation by a factor of 1/4. And as we said before, right, again, 2 to the x is here. This plus 7 is now part of my main function. So that is going to tell me I have a horizontal translation. Left 7. And you can see it's part of the exponent, right? It's x plus 7 all in the exponent. And finally, once again, this plus 2, like I said, it's like it's outside of it, right? This is, again, this portion is already done. It's all by itself. I have this kind of like an afterthought of plus 7. That is a vertical translation. Up 2. I think this is the last one before we kind of switch gears a little bit. I clicked on something. With the log, it's pretty easy, right? That's just a logarithmic function. And be careful here, right? You see that the main function, the original function, is log base 3 of x. My function is here. My main function is log base 3, and you'll notice parentheses x minus 5. Right, so that's my main function, which tells me that this is my a value. So 4 is my a. There's no negative, so there's no reflection. This is just a dilation by a factor of 4. And again, people got confused about this 3, like, oh, what does it do? It doesn't do anything because that just kind of defines what my function is. My original function is log base 3. I have log base 3 here still. That's consistent. What I do care about here is this minus 5 inside the parentheses. This minus 5 does indicate to me that this is going to be a horizontal translation. Right, because the sign does not match 5. Now we also want to be able to do the opposite. So if I'm given a function, I need to be able to write it out for myself. So I'm going to do my best to kind of color code this as much as I can. So I have g of x, as they told me to do, is equal to x to something, x cubed, and I need to figure out the rest. I'm going to just write out this one as well. Okay. because you'll see like it's very okay. Well, actually, never mind. I was talking about something else. Never mind. Never mind. Left two means I need to remember horizontal translation. That's going to be part of the x. That's why I drew the parentheses. That means it's been adopted into your function. That's why the plus two is inside the parentheses, while this up a, remember the whole vertical is going to be outside. So you really should not be thinking about, oh, like they're both like pluses. Like, what is the difference? The huge difference is this has parentheses around it, right? I'm sorry. Please excuse my dear Aunt Sally, right? PEMDAS, it's really important that we do the parentheses first. All right, the next thing I got here, they tell me I want to first reflect across the x-axis. That's going to tell me there's a negative in front, but I also have up 5. Up 5, so just like before, I'm just going to increase it by 5. And that's it. Similarly here, I'm going to first write out my g of x is equal to, and then I can see what's coming up. So I'm going to write this out first. Same thing here. Okay, just trying to color code it so you can see better, hopefully. Again, there's a reflection across the x-axis. That's telling me there's a negative in front. Left 2, right? Again, that's inside my parentheses. Plus 2. Up 1. Up 1 is outside, out here. Stretch vertically by a factor of 2. That means there's a 2 outside the parentheses. Down 3. That means it's plus 3 at the end. And left 4 means I'm going to add 4 on the inside. I notice that this time it doesn't even matter if I'm doing a different order than what I had before, because the numbers kind of go in the same place over and over again. Okay, my basic or my main function here is g of x is equal to the square root of x. This one is a great one. It's a little bit tricky here. For this one, it's shrunk vertically by a factor of 3. Now, you might be tempted to say, well, it's a vertical dilation. It's 3. But remember, this is going to stretch it out. So what you actually should do, because it's a shrinking, what happens is that this is actually going to be 1/3. Right? By a factor of 3 means you're going to divide by the 3. Right 10, this one's a lot easier. I'm going to add 10, but be careful. Don't extend out your radical, right? I'm sorry, I totally messed this up. This should be, it's right 10, sorry. It should be underneath this square root. Right 10 means minus 10. Sorry about that. All right, g of x equal to root x. And then g of x is equal to root x. All right, cool beans. All right, so again, stretch vertically. This stretching means we want to increase, right? So it is a 4, while a left 2. Again, this is horizontal. It's going to be inside the parentheses. Left 2 is plus 2, inside the radical, rather, in this case. Reflection over the x means a minus in front, while right 2 just means minus 7 under the radical, once again, because it's part of the main function. Last example, g of x is equal to 2 to the x. Oops, forgot my equal sign. G of x is equal to 2 to the x. All right. So left 3. Now, this one's a little bit trickier. That's also why I want to kind of go over it. But because I'm changing directly to x, this is actually going to the exponent as well. So x plus 3. So 2 to the x plus 3 up 9. That's going to be just as one of the other terms that I have. Stretch vertically by 3. That means I'm going to be 3 multiplied by that 2 to the x, and then reflection over the x-axis means it's going to be negative 3 instead. So maybe it'd be a better idea to kind of put this in parentheses or something. This shows negative 3 times this value. This is not equal to negative 6 to the x. Okay, that's not the same. Please don't simplify it that way. That's not correct. G of x is equal to 2 to the x. G of x is equal to 2 to the x. All right, once again, stretch vertically by a factor of 4. That means I'm multiplying by 4. Maybe I can put this in parentheses. Actually, if I did that, I would need to give myself just a tiny bit more space because I need to go left 8. Again, that means I'm doing it to the x directly, so it's part of the exponent. Reflection over the x-axis, that one's easy, just a negative in front. Last but not least, let's take a look at some graphs. I'm just going to kind of when you have graphs here, generally speaking, because I don't think we'll see graphs with dilation. So really, all you gotta do is kind of track the movement of specific points. In this case, we're tracking the vertex of my parabola. So I can see that, okay, from my F to my G, I went over 1, 2, to the right 3. So I have a horizontal translation, right 3. So what that means is, in terms of g of x, it's just, well, I know it's a quadratic, but they don't tell me what the actual equation is. This is going to be f of x plus 2, right? Outside, I'm sorry, horizontal translation, minus 2 inside the parentheses. Similarly, for this one, again, I look at that, go 1, 2, 3 to the right, and 1 down. So I do have 2 translations. I have horizontal translation, right 3 units. I have a vertical translation, down 1 unit. Again, I don't know exactly what the equation is, but I can write it in terms of my general form. I have x. If it's to the right, minus 3. Down 1 is minus 1. And finally, I can see that from F, which is my blue graph, I had a reflection, right, because I'm facing the other way. But from my reflection, I did go up 1, 2, 3, and to the left 1. So I have 3 things. I have a reflection over the x-axis. I have a vertical translation, vertical translation up 3 units, and a horizontal translation left 1 unit. So putting it all this together, I have negative f of x plus 1 plus 3. Okay, I hope this makes sense. Feel free to ask me any questions you might have. Thank you so much.